Hello children and welcome. The topic for this video is friction. It's for class 8, subject is science, and this is part 1 of the two videos in which we will be covering this topic called friction, which is a very important topic in our day-to-day lives. So here are the topics that we will be covering as part of this video and the next. So this video, which is part 1, we would learn about what is force of friction, what are the factors that affect friction, why it is caused, and towards the later part of the video, we would cover why friction is a necessary evil. That is, it is required, it is necessary, but some of the time we don't want it also. Have you ever thought, why does someone fall down when he or she steps on a banana peel? Or say if we are going in a vehicle or a car and the driver applies the brake, it slows down. Or a simple example where we throw a ball and it moves for some time, and with no one physically stopping it or disturbing it, still it stops after some time. The answer is all of these happen due to friction. So friction is a force that acts in opposite direction, opposes the motion between the two surfaces in contact, and it is always opposing the applied force. Now if we see in this sentence, there are three parts. So the first part is, it is a force that acts in opposite direction. Now if we take the example where we have thrown a ball or rolled a ball on floor and think like we have rolled it from right to left, then this force of friction that would act in the opposite direction from left to right. And coming on to the second part of the sentence, it opposes the motion between the two surfaces. So the two surfaces here are ball and floor. So it will oppose the motion and tends to stop the ball. The third part is force of friction. It always opposes the applied force. So when we throw the ball, we have to apply the force. And this force of friction that would always oppose the applied force. Factors affecting friction. Friction is caused due to irregularities on the two surfaces in contact. In the previous example that we saw, there were two surfaces, surface of ball and surface of floor, which were in contact. In this example, let's take that a book is lying on the top of table. So the surface of book is in contact with the surface of table. As you can see here, these surfaces have irregularities. These would not be visible through our normal naked eyes, but if we take a high power microscope, we would be able to view these irregularities. Now these irregularities, they would lock into one another. And then due to this interlocking, there has to be a force which has to be applied to overcome the interlocking. Now if the surfaces are rough, there would be larger number of these irregularities. So the force of friction would be greater and the force required to overcome this friction also would become more. So if we take the example, the first one where we saw that someone would fall down if he or she would step on a banana peel. In that case, because the banana surface is very smooth, it's not at all rough. So the force of friction is very less and hence someone steps on the banana peel, he or she would fall. Okay. So have you ever tried to move a very heavy box from one place to another? And if you try to do that, what is easier? If the box is already at rest or if the box is already in motion? So these questions bring us to two terms, static friction and sliding friction. So the force which is required to overcome friction when an object starts to move from rest, that is a measure of static friction. On the other hand, if a box is already moving and the force which is required to keep the object moving with that same speed, that's called as sliding friction. Now as we see here, if we try to move this box, this heavy box from rest, then that requires more force. And if the box is already moving, then to keep the box moving with the same speed, that requires slightly lesser force. Now why does this happen? Why is the sliding friction less than the static friction? Now, this would happen because when the box is moving, the box is sliding, the contact point on its surface, like we had seen in the previous example, where the book and the table, they had those irregularities which were coming in contact with each other and getting interlocked. So in the case of sliding friction, when the box is sliding, the contact points do not get enough time to lock with the contact point on the floor. So this is the reason why sliding friction is lesser than static friction. Friction, a necessary evil. On this slide, we are going to see some examples of why friction is necessary, why it is important in our everyday life. And on the next slide, we are going to see why friction is also called as evil, or like some of the time we don't want friction to be there. So can we imagine to walk or write with pen without friction? Or imagine that we have applied oil to our hands are oily, palms are oily, and then we try to catch a glass which is full of water. If the hands are oily, there won't be any friction, or the friction would be very less, and it will make it difficult for us to catch that glass of water. Or suppose we are going somewhere in a car and the driver applies the brakes, but if there is no friction, the car would never stop, or even changing the direction of car would not be possible. It won't be even possible to hammer a nail into the wall, or tie a knot, or construct a building. If there's no friction and we are trying to hammer the nail into the wall, it will never go inside because there won't be any friction and it will slip on the surface of the wall. So all these examples that we see here that prove friction is necessary. On this slide, we will see why friction is evil, or some of the time we don't want friction to be there. Friction is evil because it wears out materials like screws, ball bearings, or soles of shoes. And this happens because friction produces heat, and this heat generated causes much wastage of energy. So if you try to rub your hands vigorously, you will see that your hands become hot. This happens because when you rub your hands, because of the friction, the heats get generated. And many of the times, if we take the example like in an industry where there are machines and the parts of the machines are rubbing against each other repeatedly, that will cause heat to be generated and causes wear and tear of those parts of the machine. So these examples prove that friction is also evil at times. In the next part, in the next video, we will see how we can reduce friction, because some of the times we don't want friction to be there. And we will even see how we can increase friction, because some of the time we want more friction to be there. Apart from this, we will learn how wheels reduce friction, and we'll also learn about fluid friction. Thank you.